So first, this is the 8086. You can see there is only one 8086 ICs is there. This is nothing but a this is nothing but a this one 8086 IC. Okay. In this 8086 IC, you can see this is the latch IC. Latch IC always three, because latch IC available in the market in a actually in a 8-bit mode. So 8-bit latch IC means you required as a 20-bit address. That's why three latch IC is required. 1, 2, 3, 8 plus 8 plus 8. So that's why 2 or 3 is mentioning. If sometime it's a 16-bit for IO devices, that's why it's a 2. Otherwise, it's a 3. So latch ICs will be 3. So who will be activate the latch IC? ALE signal will be activate the latch IC. Sir, this one is nothing but a AD02 AD15. AD02 AD15. So AD02 AD15 is nothing but a coming into the address bus are coming into the latch IC, and the data bus are coming into the trans receiver. Data bus are coming into the trans receiver. So first, these AD02 AD15, dividing into the two part. One is a address bus, which is you can see, which is unidirectional in nature, and another is a data bus, which is a bidirectional in nature, which is a bidirection in nature, which is
Okay, sir.
bidirectional in nature, right? This is the bidirectional
Hmm.
in nature. Just see, this is the bidirectional bus, and this is a unidirectional bus. This is the address bus. It's clear to everyone. So first, ALE signal activate the latch IC, and whatever I am told, AD0 to AD15. So AD0 to AD15 and A16 to A19, obviously. So all those things, dividing into the two part. One is the address bus coming into the data bus, and address bus. Address bus is coming into the address bus, which is unidirectional bus is connected, Yes, and a data bus is nothing but a trans receiver, means transmit or receive can be done. Data bus how much bit? So data bus how much bit?
20 bit.
Huh?
20 bit.
Data bus
16 bit.
16 bit.
16.
So
16 bit.
trans receiver also 8-bit wise is available. So two trans receiver is required, 1 and 2. Two trans receiver is required, and 3 latch ICs is required. Just you see 3 latch IC, and you can see the 2 trans receiver. Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
So with respect to that, I can conclude that AD02, AD15, and A16 oblique S3 to A19 oblique S6. This is the bidirectional actually nature. This is the bidirectional in nature, okay, which is connected with a bidirectional bus. These bidirectional bus are connected with a data bus and connected with the address bus. Address bus, as see, this is all are nothing but a unidirectional in nature, and you see the data bus is a bidirectional in nature. So data bus, you can see, this is nothing but a data bus connected with a trans receiver, and address bus connected with a latch IC. Okay,
Okay,
it's
sir.
clear. So this
Yes, sir.
portion,
Yes, sir.
okay. ALE signal is activate the latch IC, means whenever address will be passing, that will be decided by ALE signal. When ALE signal will be high in that particular
Yes, sir.
time, the address will be passes through A0 to A19. Address will be passes through A0 to A19. Okay. Next,
Hmm.
Okay, sir.
Den bar means nothing but a activate the trans receiver. Activate the trans receiver. When den bar is full from is data enable. At the time of pin configuration, I am explaining you. Den bar is nothing but a data enable, means to activate the trans receiver, den bar should be low. To activate the trans receiver, den bar should be low, means data bus will not be worked without den bar is low. Data bar will not be worked without den bar is low, right?
Yes, sir.
What do you mean by trans receiver? Trans receiver means either transmit or received. Either transmit or received.
For
Means
receive.
transmitter plus receiver together is called transreceiver.
Sure.
Okay.
Mhm.
So
Okay, sir.
actually, dt oblique r bar, connected with dir direction, dt full form data transmit, r oblique received. When this pin is low, then data will be received. When the data will be transmit, means it will be high. So whenever it will be high, then it will be, data will be transmit. Transmit means write. Receive means read. Remember, receive means read operations, and transmit means write operations. Means I am given to any other else. I am given to any memory locations. If you are you can remembering, that is the timing diagram in 8085. I am explaining you. Whenever the data is coming from memory location to register, then extra memory read should be required. Whenever the data transfer from register to memory location, then extra memory write should be required. On these same fashions, whenever data will be coming into the microprocessor, means coming into the in 8086, means data coming into the register, data coming into the register, and data transmit means data will be sent to the memory locations, so it should be write operations. So at the time of write operation, dt bar should be high, and at the time of read operation, this pin should be low. So whether this is a transceiver working as a transmission mode or receiving mode, that will be decided by dt oblique r bar. Is it clear?
Yes, sir.
Yes, sir.
Next, I am coming into the ROM, RAM, and IO port. ROM, RAM, and IO port. IO port details described today. But whatever the RAM, I already shown to you the memory interfacing, RAM interfacing, ROM interfacing yesterday. So every memory interfacing, I already told to you that two memory devices is required. 4K into 8, 8K into 8. You can recall this one. 2
Yes, sir.
8K into 8,
Yes, sir.
2 8K into 8.
Mm-hmm.
So one is for odd bank, another is for even bank. Am I right? One
Yes,
is
sir.
for odd bank, another is for even bank. Means
Even
one
bank.
is for high bank, another is for low bank.
Lower band. Yes, sir.
Yesterday, I already explained you some memory interfacing diagram.
Mm-hmm.
Now you see that RAM is dividing into the two part. There is a dotted line, and ROM also dividing into the two part. So one is nothing but a odd bank. This portion is odd bank. This portion is even bank. That's why CSE full form, chip select even bank, chip select odd bank. There is a two chip select. One is a even bank, another is a odd bank. Means the total RAM are nothing but a two part. One is a from odd bank, another is for even bank. For say for odd bank, connected with a CSO means chip select odd, and a CSE means chip select even. Is it clear?
Yes, sir.
Similarly for ROM, CSO and CSE,
Chief select odd. Chief
chip
select
select even.
even. Okay,
For
sir.
ROM and RAM, means it's a memory is
Mm-hmm.
dividing into the two part. One is a odd bank and another is for even bank. Next is
Okay.
read bar and write bar connected with memory read and memory write. OE, instead of memory interfacing, I already explained you in 8085 also. There is a no read bar, here is only the output enable. So output enable is connected with MRD, means memory read. MEMR you can write also, no issues. MRD, memory read. So it's connected, right? Next, this
Yes, sir.
CS0, CSE, CSO, CSE, from where it will be coming? It will be coming from, from CS logic. CS logic means NAND gate, or you can say this is the decoder, something like that. So it will be depend upon the BH bar and A0 and some portions of address bus. Means yesterday, whenever I'm explaining you, some address lines are directly connected, rest of the address lines are connected for the chip select. So this is the chip select, and over here you will be get it like CSE ROM, CSO RAM, CSE RAM, CSEO ROM. You can see this one. I'm talking about the this one. CSE RAM, CSO ROM, CSE ROM, and CSO ROM. And another is CSIO, means this one.
হ্যালো
CSI,
স্যার,
yeah,
স্যার আপনি কোনো নোট ডাউন করছেন, মানে কোনো কিছু লিখছেন?
no.
আচ্ছা
So CS logic, this CS logic, I'm talking about this CS logic. This CS logic, this CS logic I'm talking about. CS logic connected with A0, connected with BHE bar, connected with some portions of address bus. Some portions of address bus means those are not connected RAM or ROM directly. Rest of the address line connected with the CS logic, right? And from that you can generate the CSE RAM, CSO RAM, CSE ROM, CSO RAM, and CSIO means chip select input output. Chip select is input output is required over here. Chip select input output.
Yes. Okay, sir.
And IO device is connected with IO read and IO write.
ওকে স্যার।
Hmm.
These are the total functions. Next, coming into the what is the MR, what is the memory read, memory write, and IO read and IO write. This is coming from the M oblique IO bar read and write. This is a demultiplex. This is a demultiplex. So whenever memory M oblique IO bar is nothing but a zero. Zero means it's a IO operations. Then it can be, if it's a zero and it's a one, then it's a IO read, it's a IO write. When memory operations will be there, means it's a high. This M oblique IO pin is a high, then you will be get memory read and memory write. Is it clear? From
ইয়েস
that
স্যার।
M oblique IO bar, read bar, and write bar, you will be get memory read, memory write, IO read, IO write. Okay.
ওকে স্যার।
And another thing is that this is a 8254 clock generator. It can generate the clock only. So it's a MN oblique MX bar connected with VCC. Means it's a given a plus 5 volt. So what will be happen? It's a minimum mode of operations. Is it clear? Just see
ইয়েস স্যার।
MN oblique MX bar connected with VCC.
VCC
Connected with VCC. So what will be happen? A high signal will be connected. Means it's a minimum mode.
Hmm. Sure.
It's clear?
ইয়েস স্যার।
Sure.
Next, going into the next page, there is a timing diagram. Just hold on, just hold on. Just you just see this is the address bus, and this portion is address bus, and this portion is data bus. Bus receive for data or whatever it is, but D0 to D15 there is a data bus. You just see in that particular time duration, read bar signal is low, as well as den bar, as well as Denver also low, as well as Denver also low. So it's a data enable. It's a data enable. And DT oblique R bar. What are the function of DT oblique R bar? Data transmit oblique received. Data transmit oblique received. Just see, it's a read cycle. It's a read cycle. That's why it's a low. If whenever I'm talking about the right cycle, then you will be see DT oblique R bar will be high. Just going down, just see right bar signal is low, as well as DT oblique R bar signal. DT oblique R bar signal now is high. So that is the difference between this one and that one. Okay.
ওকে স্যার।
Next, coming down, hold an HLD. This is the this diagram. Coming down, yes. Just see in this diagram. In this diagram also, you can see ROM, RAM, whatever it is, the same. IO device, all are same. Means this ROM, this RAM, and IO, all are basically same. So I'm not explaining you these portions again and again. All are CSO, CSE, CSO,
Yes, sir.
CSE, IORC.
Mm.
So basically same whatever I am described. So what are the basic difference? Over here also the same data buffer, 2 as a data bus, a latch is a 3 as a address bus is 20 bit. Same over here. It's a AD0 to AD16, whatever in the previous case it's available over here. Same, and same is a bidirectional bus. It's also bidirectional bus. It's a unidirectional bus. These are the same whatever I am describing. Okay, and the basic difference is that this one is the basic difference: minimum mode and maximum mode. In the previous case, MN oblique MX bar connected with
Ground.
what? MN oblique MX bar. Over here, in these portions, there is MN oblique MX bar. I'm explaining you.
Connected with VCC.
Connected with VCC. Now connected with ground. Means now it's in a maximum mode. Now it's in a maximum mode. Is it clear?
Yes, sir.
Next, the difference portions coming, as you know, in 80, if I'm talking about the pin configurations, in pin configurations, there is a no concept of ALE, there is a no concept of DEN bar, there is a no concept of DT oblique R bar, there is a no concept of a read bar and write bar. Is it clear?
Yes, sir.
You can imagine if you think about, then you can clearly just go down একটু উপরে তোলো একটু না সরি উল্টো উল্টো একটু ছবিটাকে নামাও নামাও উপরটা একটু দেখাতে হবে হ্যাঁ বাস দ্যাটস ইট just see now I am talking about these portions. Just see there is a 3 signal S0 S1 and S2. There is a 3 signal S0 S1 and S2. Just see S0, S1 and S2. These 3 signal basically generate memory read, memory write, IO read, IO write, INTA bar, ALE signal, and DEN bar and DT oblique R bar. Whatever I am explaining at the time of pin configurations, that these 8 pin also you required. If you imagine there is a 3 signal, that is S0, S1, S3, S1, S0, S1, S2. The combination of these 3 will be the 8 output. So you can get the 8 output over here: 1, 2, 3, 4, 5, 6, 7, and 8. INTA is a 1. This is a 1. This is another 4. So total 5. And these three is a 8. ALE, DEN bar, and DT oblique R bar. Right? So total 8 output, whatever is available in the minimum mode, it's also available. Just see the whatever it is. Now over here is a DEN, not bar. Is a DEN. Is a DEN. So how I can convert it into the DEN bar? That's why I am connecting a NOT gate with that. Connecting it a NOT gate with that. So DEN become a DEN bar. Is it clear or not?
Yes, sir.
This DEN will be converted into the DEN bar. Next, ALE connected with a ALE connected with a latch. Just see ALE connected with a latch. DEN bar connected with a data buffer, and DT oblique R bar connected with DIR direction. Okay.
Okay, sir.
Yes, sir.
So that is the basically same function. Basically same function. There is a no distinguish. Only distinguish those signal in 80 in minimum mode. In minimum mode, those signal are available in the pin configurations. Those signal, ALE signal, DEN signal, and DT oblique R bar signal, all are available in the IC itself. but in over here is not IC itself, it will be generated by S0, S1, S2, right?
Yes, sir.
So that is the functions. Next time coming into the 8255. Stop. Then I am coming on 8255. Uh, you can see my copy.
Yes, sir.
Yes, sir.
Just see, sir, in 8085 or any microprocessor, we are called as a, we are called as a Jagannath. Today is a, the Rath Jatra.
Yes, sir.
So Jagannath. So what is the basic difference of others God and Jagannath? I told you already. This is there is a no hand and no legs. Okay.
Yes, sir.
Yes,
All
sir.
the gods have the hand, legs, everything, but in Jagannath there is a no hand, no legs, nothing is there. So 8255 is basically used to generate the false hand and legs for microprocessor. False hand and legs means to give the Jagannath hand, so you connect externally, right? So 8255 is basically given the hands. Is it clear, everyone?
Yes, sir.
Means uh, say mm, if I want to catch hold of Bindu. So Bindu is not coming every day, and Silpa also is not coming every day. So I am if I am doesn't have any kind of hand, means in the college. So I will be creating the hands using Haldar, Onkit Haldar. Onkit Haldar is my hand. Onkit Haldar will be connected with Bindu and Silpa. So this is nothing but a Onkit Haldar is nothing but a helping hand of me. So is called peripheral IC. Is called peripheral IC. So 8255 also a peripheral IC, programmable peripheral IC. Programmable means it is controlled by you or it is
User.
controlled by user.
Hmm.
Okay.
Okay,
So
sir.
8255, whatever the how many hands is there with a 18255, those are described today. 18255, there are three hands. Remember, one is called PA, full form port A, another is called PB, another is called PC. In our hand, how many fingers is there?
5.
5.
5. But in port A, there are 8 fingers. That's why the name is PA0 to PA7. Like smallest finger, right hand smallest finger, right hand next smallest finger, something like that. Ring finger means I'm given a name.
Yes, sir.
So
Hmm.
every pins, every port, there is 8 pins, so 8 pins have a different name, PA0 to PA7. Okay.
Hmm.
Similarly, PB, similar, 8 pins is available. 8 pins is available. Again 8. So name is PB0 to PB7. Okay. Sir, how many
Yes, sir.
hands we have?
2.
2. And each hand, how many finger?
5.
5.
5. Each hand, we have a 5 fingers. Sir, I need 3 hands, but less number of finger. So how I can do it? I can do it? Just I am cut it from that particular portions. Just I'm cut it from that particular portions. So these 2 finger will be different, these 3 finger will be different. This 2 finger will be different, this 3 finger will be different. Is it clear?
Yes, sir.
Yes, sir.
So there are two different, hand will be created parallelly. Number one, if I am cutted this one, so these 2 finger with a small hand, this 3 finger with a small hand. If I have a 6 finger, so it will be equal like three fingers. Am I right?
স্যার মিডল ফিঙ্গার দিয়ে যদি কাটা হয় তাহলে তো একদম ইকুয়াল হয়ে যায়।
Middle fingerটাকে তো কেটে দিলে নষ্ট হয়ে যাবে। Finger I cannot cut it. So port B, port C, also available the 8-bit or 8 pin. It dividing into the two part. One is called PCU, another is called PCL. PCU means PC0 to PC4. Sorry, PC3. And sorry. PC0 to PC3, and port C upper PC4 to PC7. So 4 finger, right?
Hmm.
So
Yes.
with the help of 18255, we have two 8-bit ports, two how many bit ports?
4.
Two
4 bit.
4-bit ports. Means we have a 3-port or 3 hands, whatever you say. Port A, port B, port C. Port C dividing into the 2 part, it's a port C upper and port C lower. Is it clear?
Yes,
Yes,
sir.
sir.
Very good. That's a
Yes, sir.
port A, port B and port C.
4 C.
We have, there is another thing is that brain. In 8255 there is have a brain. In that particular brain you can write anything. This, what are the functions of port A, what are the functions of port B, and what are the functions of port C, you can write. So that's why there is another register is there. It's another thing is there, they called is CWR, just like a brain of a human being. CWR, full form control word register. Okay.
Yes,
Yes,
sir.
sir.
Clear? Remember one thing, in 8255, there is a pin, name is A1 and A0. Combination of these two, selecting the port A, port B, port C and CWR. If 00, then PA. If 01, then PB. If 11, then 10, then PC. And if 11, then CWR. Okay.
Hmm.
00 port A, 01 port B, 10
Yes,
port
sir.
11 CWR. Means you want to get the data from port A, or you want to send the data into the port A. The value of A0 and A1 should be 00. You want to send a data through port C. So the value of A0, A1 should 10. Either you are transmit or receive through any kind of port, the value of A0, A1, something like that. Remember this table. Is it clear?
Okay, sir. Yes,
Yes, sir.
sir.
The next portions, I will be explain you the what are the modes and sir, what are the functions of your right hand? You can say easily. Am I right?
Yes, sir.
Yes, sir.
Means in your brain it is already stored what are the functions of right hand, what are the functions of left.
Yes,
Similarly,
yes, sir.
how we can write into the CWR so that port A, port B, port C, whether input port, whether the output port, whether the different mode, whether the bidirectional mode, how it will be worked, right? So just going into the next, that is the CWR of 8255. CWR is a 8-bit register. Right? Control word register. Okay, 8 blocks is there. This bit called D7 bit. This is called D0 bit. If this bit is 0 or it can be 1 because it's a binary. Okay.
Yes, sir.
If
Hmm.
0,
Yes, sir.
if 0, then it's a BSR mode. If 1, then it's a IO mode. Okay.
Sir, BSR full form ki?
Bit set reset. Bit set reset. IO mode is an input output mode. I am talking
Yes.
about the BSR mode later on. I am first talking about the IO mode. If it is the IO mode, then these 2 bit, it may be 0 0, it may be 0 1, it may be 1x. 1x means
Sir,
1x,
neither even nor
1 0 or 1 1. 1 0 or 1 1.
1 0 and 1 1.
It's a call mode 0.
Mode 0.
It's a call mode 1.
Hmm.
And it's a call mode 2.
1.
Mode 0, there is a name is called simply IO mode. Simply IO mode. Simply IO mode. Simply input output mode. Name you should be write down over here. Simply IO mode. As your exam, you know, in a multiple choice question, so this kind of questions will be asked. Simply IO mode. Okay.
Okay. Hmm. Hmm.
Mode 1 is called handshaking mode. Handshaking mode. Handshaking mode. Handshaking mode. Mode 2 is called bidirectional mode. Mode 2 is called bidirectional mode. Mode 2 is called bidirectional mode. Okay.
Yes, sir.
Yes, sir.
Most important mode is mode 0, which are used in normal conditions in everywhere. Mode 0. So I am explaining you the mode 0. This is for PA. This is for PCU. This is for PB. This is for PCL. What does it mean? In simply IO mode, if this bit is 1, means it's an input. If this bit is 0, means it's an output. Is it clear or not?
Yes, sir.
Means port A, whether it will be used as an input or output, decided by this bit. If I am given over here 1, then it will be input. If I am given over here 0, then it will be output.
Output.
Similarly,
Yes.
similarly for PCU, full form port
Okay.
C upper. Full form is port C upper. So what is the function of port C upper? What is the port C upper? What is the port C upper? If it's a, again, it's a 1, then
Input.
input, input,
Input.
and
And 0
same,
mean
same.
output.
0 is output. Similarly for port B, similarly for port C lower. Remember this bit again for these two. It's called group B. It's called group A.
Okay.
It's called group B. So group B may be 0 for mode 0, 1 for mode 1. Means you are going into the simply IO mode, then also can be go into the mode B for mode 1 for these 2 pin PB and PC lower. Means handshaking mode. Okay. So
Hmm.
as IO mode, or this always it is a 0 whenever you are using the mode 1, sorry, mode 0. means is simply IO mode. Okay.
Okay, sir.
So now the questions, how the questions will become. Okay.
Hmm.
If the value of CWR, if the value of CWR is 98H, if the value of CWR is 98H,
Hmm.
okay,
Yes, sir.
Yes, sir.
then calculate. Now, explain it. Sorry, explain it. Explain it.
Hmm.
Okay. So if 98H in CWR, just converting into the binary. 1001 1000, right? So if
Yes,
this bit
sir.
is 1 means
1 means input output mode.
uh, IO port, IO mode.
Hmm. Yes,
Okay.
sir.
This 20
Hmm.
means
It means mode 0. Simply input output mode.
mode 0. This bit is 1 means
Input
which one? Port A input.
port A. Hmm.
This
The
one
input.
PCU.
port C
Port C
upper
upper,
Port C upper,
input.
one input.
input output.
Hmm.
This is again mode 0.
0.
This is PB. What are the PB? Port B. Port B
P.
0 means
Output.
0.
0 means output. This one port C lower.
Port C 0 lower.
It's a also output. What is the
Output.
output?
Put.
As it's a 0.
Hmm.
Okay.
Yes, sir. Hmm.
Next question is calculate the value of CWR
Hmm.
if all the port used as a output port.
Calculate the value of CWR.
Yeah, if all the port used as a output port.
Sir, calculate the value as a
Calculate the
The
value
value
of
of CWR
CWR if
if all the port used as a output port.
output port.
Hmm. Follow the one.
Tell me the value. What will be the value? Means now you should be calculate what will be the value. All the port will be used as the output port.
Hmm.
So it should be IO mode.
Yes, I would mean 1.
IO mode means
1.
it's a 1. And next you will be calculate. I will not say anything.
Hmm. Yes, sir. Then 0.
What will be the value? Given me the hexadecimal value.
This one 0. The 0, 1, 0, 0. No, sir.
I don't know, sir. What? Just tell me the
The
value.
ball.
What will be the value? What will be the hexadecimal value? Anyone is doing?
1, 0.
sir.
It's very simple. It this one. 91 is very toughest. That's why I'm 98.
Sir,
Yeah.
8,
Huh?
80. 80.
One answer is 80. Any other answer? As there is a no
80.
answer, so 80 is the correct answer. As there is a no answer. Next, it should be mode 0. So 0, 0. Next, all are output. So PA is the output. PC upper will be the output. It should be mode 0. PB should be output. PC lower should be output. So all are 0. So it will be 80. In hexadecimal, it's a 8.
80.
0. So 8. Is it clear?
Yes, sir.
Yes, sir.
So this is a value of CWR. This is the value of CWR. Okay.
Yes, sir.
So now I am talking about the BSR mode. So some port may be input, some port may be output, then calculate the CWR. These kind of questions may be occurred, right?
Okay.
Next, I'm talking about the BSR mode. It's a BSR mode. Full form, beat set reset mode. So this bit should be 0. As BSR mode, it should be 0, right? These 2 bit, these 3 bit actually, no function. You can give 0, you can give 1, no problem at all. Okay? These 3 bit, if it's a 0, 0, 0, then you see PC 0, 0, 0, 1, then PC 1. Similarly, 1, 1, 1, it's a PC 7. Okay?
Okay, sir.
PC 0 to PC 7. Any bit you can set or reset. Only port C. Only port C you can set or reset. So PC 0,
Okay.
PC 1 up to PC 7. And the last bit, if it's 1, then it's a set. If 0, then it's a reset. Okay?
Yes, sir.
Note it down. Done?
Yes. Done.
Next question is coming. PC3 set. What will be the value of CWR? PC3 set.
Set. 53 set
Means this bit should be set reset, means it should be BSR mode.
Yes. 0.
0. 0.
3 is
Next
not
3.
any function, so I am
No,
given a
no
0.
function. हाँ. Sir,
PC3
PC
means 0.
3 बोलें तो.
Yes.
0 1 1.
0
0
1
1 1.
Set means
0.
set means 1.
1.
So it's a 0, it's a 7.
7.
So 7 will be the value of CWR.
Hmm.
Okay.
Yes, sir.
PC7 reset. What will be the value of PCWR? PC7 reset. What will be the value of CWR?
7. 7 reset.
Reset.
Okay, sir. Okay, sir.
Sir, 0 here.
0.
14. E.
E, 0 E.
0 E will be the correct answer. Where is the rest of the student? Is now today is this is the first time I am given this one. So you can give the answer. So Shweta Club is very easy. Next, I will be explaining some different. That is the interfacing with 8085, 8086 to 8255. You can interface with 8085, you can interface with 8086 with 8255.
Okay.
Okay. What are the requirement of 8255? First, I'm telling you what are the requirement of 8255. Means क्या function ये करेगा? Whether it's required to interface and whether it's not required. Interface means connections, connected. Tell me.
Yes, sir.
Tell me whether it's required or not.
Sir, can you please repeat one?
8255, we will be do the interfacing. But whether it's required to interface with 8255 with 8085 or 8086. If
Yes, sir.
required, why?
It is required.
Why?
It is
And if not
required.
required, then there is no questions at all.
Yes, sir.
If it's required to interface, then the clause is why you want to interface 8255.
Sir, the basic meaning of interfacing is connecting those two.
Those two, right? But you
Okay.
know, say I'm interfacing with DMA controller, means direct memory access, transfer
memory
memory
access.
locations to another memory locations.
Hmm.
Okay.
Yes.
Next, I want to interface A to D converter. A to D converter means analog to digital converter.
Yes.
Means analog data input and the digital data will be output because microprocessor working with a digital data. So A to D interfacing will not be there. So you cannot do anything. D2A interfacing. In the real world, all the data is nothing but analog. But microprocessor and microcontroller, whatever it is, working with the digital data.
Digital data.
So A to D interfacing and D2A interfacing should be required. Similar kind of whether 8255 interfacing is required or not required.
Interfacing is required or not. Sir, required.
Debajyoti,
Yes, sir.
just think about whenever you first time you meet with Ankit in the next session, means you know after the lockdown, what will we do? In the first,
We will greet each other
anything?
or hug
Huh? Hug
or handshake.
handshaking.
Yes, sir.
Am I right?
Yes, sir.
This is nothing but a connection, interface between the two devices, between Ankit and between Debajyoti. Am I right?
Yes.
Then whatever you are discussing, that is the different part, but this is nothing but interfacing. So without hand, how you interface? It's not possible at all. Never you cannot interface without your hand. So if you want to interface with A2D, with D2A, with
then we need the hand.
Without 8255 is nothing. You cannot interface with any devices.
Yes, yes.
Without this hand, हमारा ये हाथ ही नहीं रहेगा तो तुम क्या करोगे? हमारा हाथ के साथ हाथ मिलाओगे कैसे?
Yes.
8255 is used to generate the hand, right?
Yes, sir.
So basically, without 8255, you cannot interface anything.
Okay, sir.
Is it clear?
Sir.
Yes, sir.
So first you should be interface with 8255, then you can interface with any other devices.
Mm.
Clear?
Yes, sir.
Next, these type of interface are two types. These type of interface are basically two types. One is called IO mapped IO, another is called memory mapped IO. One is called IO mapped IO, another is called memory mapped IO. IO mapped IO and memory mapped IO. Is it clear?
Yes, sir.
Yes, sir. I am not tired. Yes, sir. Done.
So memory mapped IO and IO mapped IO, right?
Hmm.
So what are the basic difference? Memory mapped IO means input output device. Memory means memory address. If I'm talking about the in 8085, what are the address bus? How many bit of address
16.
bus?
16-bit of address bus,
16 bit of address bus in 8085.
A0
Hmm.
A15,
And for data 8086,
20-bit of address
20
bus,
bit.
20 bit of address bus in
Hmm.
8085, in 8086. So this is called
Okay.
memory address. This is called memory address, right?
Yes, sir.
Next,
Yes, sir.
I'm talking about the IO memory map means memory address. Whenever you are given the address, say from which memory location to which memory location, 00000 to FFFFF.
Yes,
Something
yes, yes,
like that.
yes, yes. Yes.
Is it clear?
Yes, sir.
Yes, sir.
So next, next is that IO mapped. In 8085, this IO address is 8-bit wide. In 8086,
It's 16 bit wide.
it may be 8-bit, it may be 16-bit, depend upon the functions. So maximum
Hmm.
can be 16-bit. So memory mapped IO, how many devices you can, connect it? For 8085, it will be 2 to the power
Two
16.
devices.
And for 8086, it will be 2 to the power 20.
20.
Hmm.
This is the number of devices you can connect. But in IO mapped IO, you can connect 2 to the power 8 and 2 to the power 16 in 8085 as well as in 8086. So how many devices? 256. To the 16 means within the 64K memory, devices you can connect. Is it clear?
Yes, sir.
So what are the advantage and disadvantage? So memory mapped IO means you can connect more devices.
Hmm.
You can connect more devices.
yes sir,
Okay.
yes sir.
So next, so this is advantages, whatever you are thinking about, right?
Yes, sir.
But for 8085, 8085 better than me. That's why I'm talking about the 8085. For 8085, what are the instructions? Like LDA, like STA, say like 8500, 8600, something like that. For in 8085, what are the instructions? Like in 40, out 50, etc. What does it mean, sir? So this is how much byte?
Right?
3 byte.
Yes, sir.
This is how much byte?
2
2
byte.
byte.
2 byte.
2 byte.
So in IO mapped IO, sorry, in IO address, whatever it's IO mapped IO, is obviously it's IO mapped IO. IO is a device. Input output is a device. IO is the mapped, means using input output address. Using input output address. This is the input output address. So in IO mapped IO, means IO address से IO device को address करना, memory address से IO device को address करना. So in IO means it's a 2 byte. So less memory required. Am I right?
Yes, sir.
Number one, how many machine cycle required or how many T-state is required?
LDA 3 bit. HCH. Cycle.
Opcode fetch plus memory read plus
Memory read.
plus extra machine cycle, maybe memory read or memory write. It depends upon
Right.
the LDA. If for LDA it's a memory read, for STA it's a memory write. So maybe a memory read or memory write, whatever it is. So how
In
much?
13.
4 plus 3 plus 3 plus 3. How much?
4 plus 3 plus 3. 13
13.
T state.
And over here 4 plus 3 plus 3 means opcode fetch plus memory read plus memory
10.
read or memory write, whatever it is. For in it is read, and for out it's a write. Because it's a 2 byte instruction, so opcode fetch plus memory read is not required. Only opcode fetch plus memory
Yes,
read
sir.
is required.
10 pieces.
Plus extra machine cycle. So T state is is required is less, means it is faster. IO mapped IO is the faster with respect to memory mapped IO. Okay.
Yes, sir.
Okay, sir.
Next. Next is that how to interface. And whatever the physical address. So write down interface A8255. Interface A8255 with say first with 8085. Basically same, just with 8085, and calculate the address of port A, port B, and CWR. Calculate the address of port A, port B, and CWR. A8255. Okay. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Next it is this is a data bus D0 to D7 connected with a D0 to D7. Okay, this is PA, this is PB, this is PC. Next two pin is a very important. One is called A0, another is called A1, is connected with A0 and A1 microprocessor. Next, all other lines like now I am talking about the IO mapped IO. IO mapped. IO mapped IO. Okay. I am talking about the
Hmm.
IO mapped IO. So for IO mapped IO, address is 8-bit wide in 8085. So what will be the address? Say connected directly, connected with a NOT gate, connected with a NOT gate, connected with a NOT gate, connected with a NOT gate. Tell me. Is it clear?
Yes, sir.
Yes, sir.
So A0, A1, this is A7,
স্যার এই পেজটা একটু
A6.
এটাই পড়বেন মানে ফোনে কি আসছে না।
হ্যাঁ
হ্যাঁ স্যার।
বলো।
আচ্ছা তখন আসছিল না পেজটা, দেখা যাচ্ছিল না।
Oh, this is A2. Okay. So A0 to A8 is connected. Rest all are not connected as these are IO devices. As these are IO devices. By default, those will be 0, logic 0. Okay.
Yes, sir.
হুম।
So next, what will be happen, sir? What will be the address of port A? What will be the address of port A? Address of port A. What will be the address of port A? A7, A6, A5, A4, A3, 2, 1, 0. Right?
হুম।
To select this chip, this is a connected with a CS bar. To select this shift, it should be 0.
0.
And it should be, all R should be
1.
1. So A2 just connected directly, A7 connected directly, right?
Yes, sir.
Yes, sir.
So A2 and A7 should be 1. Rest all are connected with a NOT gate. So it should be 0. If I'm given 0, then it will be coming 1. Is it clear or not?
Yes, sir.
If I am given 0, then it will be coming as a 1 because NOT gate is there.
হুম।
So port A, what is the value of A0 and A1?
One.
This is clear to everyone?
Yes, sir.
Yes.
How?
sir.
Why 10001?
হুম হুম।
Next, tell me what is the value of A0, A1 for port A? I am given a table to you already. I'm telling you that it should be remember.
1 is equal to output, input, and 0 is equal to output.
Up this table A0, A1
Oh, अच्छा, अच्छा, अच्छा.
for
It's a
for
zero.
port A.
Sir, 0, 0.
0
Zero.
0 0.
0 0. So 0 0. So what will be the value? It's a 8. It's a 4. 84.
4.
The address of port A is 84. Okay.
Yes, sir.
Yes, sir.
Next is
Port B.
port B. What will be the port B? 1 0 0 0 0 1. It cannot be changed. What will be the value of A0 and A1 for port B?
0, 1.
0 1.
So it's a 8, it's a 5. So port B
85.
will be 85. Next 1 0 0 0 0 1 1 0. It's a port C. It's a 86. Next
Yes, sir.
1 0 0 0 0 1 1 1. Next CWR 87. Is it clear? Only A0 and A1 will be changed. Only these two parts will be changed. Only these two parts will be changed according to this table. Okay.
Yes, sir.
Yes, sir.
Next, my second questions. If the address of port A is 48,
Mm.
then draw the interfacing diagram. Then draw the interfacing diagram and calculate port A, port B, port C address.
So,
And calculate port A, port B, port C address. Tell me, draw the diagram and give it shown to me. First, write down address of port A, then just write it down. Port A. Address of port A. So what will be the address of port A? Is 40. It's a A0, A1, A2, A3, A4, A5, A6, A7. Am I right?
yes, sir.
Yes, sir.
What will be the diagram? All are connected, not get. All are connected, not get, except A7. All
Yes,
are
sir.
A7.
the A2 also connected with the not get.
Mm.
Mm.
Okay.
Yes, sir.
Sorry. It's a 80. It's not a 40. It's a 0. These one should be 1. Am I right? Sir, আগেও
Yes,
right
sir.
ছিলেন, এখনো right. So the changes will be that A7 is a not get, but A6 direct.
Direct.
Because A6 is a 1. So same diagram you should be draw. First draw the diagram. Done?
Yes. So
Next, calculate the address of port B. This will be 0, this will be 1, this will be 0, this will be 0, this will be 1, this will be 0. It should be 0, it should be 1, it should be 0. So what will be the value? It's a 4, 4, 1. It's a 4,
42, 43.
so 43. This is the address of, this is the 43, 43, 42, 41. Okay.
Yes, sir.
Yes,
Done.
sir.
Okay. Next, what
Yes,
will be
sir.
the memory mapped IO? If I'm talking about the memory mapped IO. Next, write down. If address of port A, if address of port A, if address of port A
Hmm.
CD 50, CD 50,
Hmm.
memory mapped IO, then draw the interface diagram. Then draw the interface diagram with 8085 and 8255. With 8085 and 8255.
Eight two five five and 80.
8085.
Okay.
Actually 85. Next, what are the difference between 86? I will be explaining you tomorrow. It's a very simple difference. Only the address will be changed. Nothing.
Yes, sir.
So first, you should be write down PA address. Something like that. A 15, A 14, A 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay.
Hmm.
And the CD means in binary 1 1 0 0 1 1 0 1. This is C, this is D. What is 5 0 1 0 1? This is 5. What is 0? 0 0 0 0. Okay.
Yes, sir.
Next, the diagram, only the changes will be this NAND gate is a big NAND gate. It should be A2 to A15. It should be A2 to
A15.
A15.
A15. And which one is a 1? That will be
Directly
directly
connected,
connected. What is a 0? That will be
connected with a NOT gate.
connected with a NOT gate. Draw the diagram and shown to me. It's a very simple one. What will be the port B address? In the last 0 1. Port C address 1 0. When CWR is 1. Means it will be the same. These portions will be unchanged up to A2. All are same. Only changes is A0 and A1. Calculate the value. It is CD51, CD52, CD53. From the diagram first. একটু হাতটা স্টেবল কর বাবা।